Good morning, everyone. Let me begin by setting the context clearly. This is not a deep technical interview. We are not here to test advanced subject knowledge. We are not going to evaluate you on complex software development, prompt engineering, or detailed AI algorithms. This session is designed as an interactive discussion. Our objective is very simple. We want to assess your awareness. We want to understand your clarity of thought. We want to evaluate how you connect concepts. We are not expecting expertise. We are not expecting perfection. However, we do expect awareness. At a minimum, we expect you to know what is happening around you in the IT ecosystem. Have you been following technology trends? Are you aware of developments in AI, cloud computing, cybersecurity? Have you gathered knowledge from social media, professional platforms, newspapers, journals? Yeah, isn't it? What exposure have you built for yourself? That is what we are interested in. Now, let us start with fundamentals. Every computer system can be divided into two major components: hardware, software. Hardware refers to the physical components: keyboard, mouse, monitor, processor, memory. Not just computers, even mobile phones and tablets contain hardware components such as processor, RAM, storage, and touchscreen. To simplify this concept, think of the human body. Hands, legs, head, internal organs. These are physical structures. That is hardware. Now let us move to software. Software controls the hardware. Software provides logical instructions. Software enables functionality. When you power on a computer, the operating system loads first. Only after that does the system become usable in process. Applications such as MS Office, development tools, or mobile apps are examples of application software. If a software component supports the system itself, we classify it as system software. If it supports user tasks, we classify it. For example, Android OS controls mobile hardware. iOS controls Apple devices. Without system software, hardware is non-functional. Similarly, in the human body, biological control mechanisms such as heartbeat and neural signals function like system software. Skills such as swimming or driving function like application software. So the mapping is clear. Body equals hardware. Biological control, system software. Learn skills equals application software. This structure applies universally. Now let us move to computer languages. A computer is an electronic device. It understands only two states: signal present T's, signal absent. We represent these states as 1 and 0. This binary system forms machine language. Machine language consists entirely of 0s and 1s. However, writing programs directly in machine language is extremely difficult. To simplify development, assembly language was introduced. Assembly language uses symbolic instructions. However, assembly language is machine-dependent. A program written for one processor cannot directly run on another processor. This created scalability and development challenges. As a result, high-level languages were introduced. These languages are closer to human language. They are easier to write and maintain. Examples include Fortran, Pascal, Python, Java, C#. However, historically, high-level languages were used mainly for application software. Operating systems, which are system software, were still written in machine language. That created a major limitation. At Bell Labs, Unix was developed. Initially, Unix was written in machine language. Later, Dennis Ritchie developed the C programming language. Unix was rewritten in C. This made it machine independent. This was a defining moment in computing history. From C evolved C++, C#, and the .NET ecosystem. Even today, most system-level foundations rely on the C family. This is why understanding fundamentals. Now consider cloud computing. Earlier, Unix followed a centralized computing model. The server handled the major processing. Modern cloud computing follows a similar architecture. Cloud servers handle back-end processing. Clients send input and receive output. Same principle. Expanded scale. Now let me clarify why we are discussing all this. Before discussing agentic AI or quantum AI, you must understand the foundation: hardware, operating systems, programming languages, compilers, system architecture. Without foundational clarity, advanced concepts cannot be understood properly.